Welcome back, everybody. Once again, I'm Stephen Foskett. I organize the Tech Field Day event series, and we are working with Aruba here to bring you their 11AC news, but also to bring you some independent, unbiased, non-influenced, non-bought and paid for discussion. And that's what this is. So this is the Tech Field Day Roundtable. This is sort of one of our signature things, which is basically to get these guys talking tech. Again, all of these folks are selected because they are technically knowledgeable. They are all independent. None of them are analysts. None of them work for any of the companies in this space. They all have a blog or a podcast or seminars or teach Wi-Fi or all sorts of other areas, other ways that they give back and contribute to the conversation. Again, there's been a lot of great conversation online as well. We are using the 11AC hashtag. Looks like other people are also using the 11AC hashtag, but if we can flood them with lots and lots of commentary on this roundtable, that would be awesome. We also still have Kirthi and Pascal here at the table, and so now is the time when you folks are going to tell us what you think of what was said, and let's try to keep this very discussion-oriented instead of Q&A around here at the table. Again, each of you has a microphone, and this little R2-D2 in the middle will be moving around and looking at you as you're talking, so try not to get too distracted by that. So who wants to lead off the discussion? Blake? Well, because I know that you've always got something to say.
Well, wait a minute. Let's hear. What can I say? No. Sure. So I guess, one of the things I've seen on the Twitter feed today also is kind of made sense to me too, is why are we focusing so heavily on voice in the discussion of 802.11ac when really, for me, when I see AC, I think of high density. I think of, the auditoriums where everybody's going to be starting to stream that same video at the same time. But you guys' focus this morning really was along voice and sticky clients, which, Peter, you and I had a great conversation in the break about the sticky clients are definitely a huge issue that we're seeing. And it primarily affects voice for the most part, because if your sticky client goes up, you start having bad roams, your call goes down, your MOS score goes down, and the call falls apart. And everybody's like, why isn't it like my cell phone? I need it to be like my cell phone and just work, which if you have AT&T, it doesn't, but that's another story. So, why are we focusing on voice and link for an AC product launch when it seems more along the lines of video? And I know Link does video, so I wasn't sleeping there. I just was paying attention to that one, but.
Yeah, I think voice, fundamentally it is more to do with the phone itself, right? And it's not so much the voice traffic pattern, because ultimately what I've seen is a lot of the link sessions tend to end up as video sessions. If they graduate from an IM, they become a voice chat, and soon enough they're going to be a video session as well. I think the focus on voice was more around this nagging issue that I keep hearing about, I still need to pull that cable. And the cable is being pulled for the desk phone. And a lot of times, our customers themselves admit that the desk phone is just sitting there collecting voicemail. And we actually use our mobile phones to return the voicemail calls and even check the voicemail using our mobile phone. Of course, we're using probably cellular for doing those things rather than Wi-Fi. So the idea was to truly enable a right-size network, essentially, to be able to go do all wireless, because we've been talking about it in the industry for years now. And it all comes down to not having to pull cable. And to us, that translated to getting away from that comfort zone of having the desk phone there. Because if you really get into the land of Link or any other UC for that matter, you truly get that sense that you can be very well connected through all these different mechanisms that are out there. So perhaps we focus on voice more from a right-sizing perspective to get rid of the desk phone rather than the traffic pattern itself. From a traffic, I think it's going to be video, clearly, that will overwhelm everything else on the air.
One of the other things you mentioned, the sticky client piece. 11AC doesn't necessarily exacerbate the problem, but it highlights it, right? Because the best data rates, you're only going to get about a 36 SNR. As soon as you get a little farther out, so when you move out of that center bullseye, you're falling back to 30, which is 11N. So really get the most out of your 11AC rates, you need to be optimizing that client connection to have the best SNR. And that's where Client Match can come in to optimize it and help you get the most possible out of your 11AC network.
I want to bring up a topic while we're talking about this. What we saw this morning, I think it's great that you have built-in airwave links into Link and everything. But from those of us who practice in the industry, we need a whole new set of tools to even troubleshoot, analyze, and do everything. It's not like you're going to always have well, we should always have an airwave there behind you. What kind of portable tools do we have in AC that allow us to see these things? And is there a way we can get into that, perhaps that Link SDK from the API from a handheld? So when I'm wandering around, as it is now, we go out looking for problems, and we have our sets of tools we all bring with us that are today not capable of doing that. So anybody have any ideas on tools that you'd like to see?
Well, one of the difficulties we have with even with the Microsoft's platform is having those kind of tools that allow you to take the wireless drivers and troubleshoot an actual packet level connection of what's going through. There's like a lot of monitor drivers on the Wi-Fi side that just aren't available on the Microsoft platform, which is one of the reasons I have a Mac. You can do that type of packet captures from the Macintosh, and you can't do it very easily on the Microsoft platform. Not so much a criticism directly of Microsoft, but it's just that those drivers aren't being written to be able to have that monitor mode functionality.
Yeah.
Backing up one step, I think, correct me if I'm wrong, the Link server gives you visibility into a lot of the same information.
So we're not going to have access to that server necessarily. You know, we're looking at it from when we drop ship it into a customer site and we're said fix the problem. Chances are Link is ran by a different group that doesn't want anything to do with us because we're playing the whole network versus server game. Who's to blame? Whose fault is it? You know, oh, it's never the network. Oh, it's never the server. It's nobody knows. Nobody cares. They just want the problem fixed. That's our job to figure it out. So we're not going to be able to get that access into that server to get the information. So I think when you're talking about the SDK or the diagnostic API, and it being shipping to partners, Ryan and I, the first thing both of us were like, oh crap, a closed API. You know, we don't want closed APIs. We want openness. That's the big thing. That's what, Cisco, all of their APIs, you have to join their developer program for initially to get access into anything. The data's there. It's my data. Just give me access to it and let me build the tools, because then you're going to get feedback. You're going to get more tools that are going to help you in the long run. If you have hackers like Ryan and I sitting there trying to figure out what we can get out of the data, then we can work with people like MetaGeek to get the tools we want. And we can work with Fluke.
I would just like a tool that I could walk out wirelessly and catch it all. It's all wireless traffic anyway. Why do I need to talk to the hardware side? It's in the air. We should be able to do some diagnostics.
Right. Let me just actually the point about it being closed. We make that statement. So actually, ironically, just a week before I came here, we had a discussion because when we were doing the DEP program, we had to contain it. We can't just, even though we announced the API, we just can't let everybody just randomly put it on their front ends and say, okay, now what's it going to do? So we had to contain it. But what we did discuss was how do we make it generally available to everybody? So we're working through that process so that any customer can download that. And then the question is, how do we tie that into your tools? So today, someone has to deploy it on the front end, which is not going to be the most practical when you have to go through change management and all that. Right? So we are looking to eventually package that as part of all Link deployments, as Link shipments of versions as versions come out. So we're looking to get it as maybe a CU update, we call it cumulative updates, so that'll be shipped in. So it might take a while before it gets into all the Link deployments, but then you can just, the API can just instrument yourself. Right, your tool.
Yeah, and I love this because I just saw that Trent from MetaGeek just said he'd love access to the API to get it into their tool. So I mean, it's there's some
your second partner is a diagnostics partner.
And our second partner is a diagnostic, but it's not. I think it's not. It's more of a system diagnostics
right.
Versus what you're saying is I'm a guy. I want this API tied into my tool. So when I go in, I can look at what's going on, and because right now troubleshooting is what was your MAC address from that? And it's your SIP URI is this, and what machine you did from? What's the IPI? What's the MAC address? Let's go look at the logs. And it's very hard.
So there's two different kind of scenarios that we go through as professionals. We have the system level group where they're doing centralized log management. They've got maybe the types of servers you're talking about to do some sort of centralized logging from a large enterprise. Then for us, a lot of the time as wireless engineers, we're going in to troubleshoot spot problems.
Yes.
And so we need tools on our laptops to be able to say, from a client point of view, how can we troubleshoot this problem? How can we figure out what's going on here? Quite often we'll go back to using packet level analysis to see what the client's seeing from a packet level and try and do troubleshoots that. Having access to those types of APIs from a client perspective is invaluable to help us do that kind of troubleshooting.
And certainly speed up the troubleshooting process.
Okay,
immeasurably.
so I think it's great. I mean, do you have someone you buy it to, or you go get, like the Wiresharks of the world, and that's you guys all use Wireshark? Because
Yeah, you'd be looking at the OmniPeaks from Wild Packet Software. You'd be looking at MetaGeek. You'd be looking at Fluke. Fluke actually attempted to do this with the Cisco product line, the Vo-Fi Analyzer. At one point in time, they were looking to tie in where if you had a 7921 USB connected to your laptop running the Vo-Fi Analyzer, you could get some of those metrics as well. So I mean, there's definitely the need for it out there. We're not going to hit up just mom and pop coder shops out there. You're going to have to start looking at the larger analysis tools that are.
So if you have connections, point them my way. You have my connection. I'd love to. I think it's a
I don't
brilliant
think anybody
idea.
here has connections to it.
We were looking from a system level, and I think it's brilliant the idea that it helps troubleshooters that they can get access to that.
Yeah, the people writing the tools are the ones you need to talk to. The system level, you're not going to get anything from.
No.
Well, we have a system diagnostic system, but you have to spend hundreds of thousands of dollars. That's what you're saying. You just want it in your tool set. You come in and it's instrumented. So I'm running the program and the partnering, so I'd love to talk to anybody you think's of interest. So I'll leave it to you guys.
How about another topic? Designing for AC. We're kind of announcing today.
Yeah.
We do Wi-Fi designs. Where do we?
I think one of the
Where we
things
move.
that came out of this today is we're talking about having much denser AP deployments and using essentially the things like client match to move clients more around the network.
Right, I would come back to that much denser piece and say it's going to depend. Right, if you're an ABG network or if you initially deployed for coverage, then I'd say yes, you're a much denser network. I'd say if you deployed your 11N for capacity, you're probably okay.
Sure.
I'm guessing you're probably not going to be deploying for 1,300 megabits ubiquitous coverage everywhere, given the SNR requirements of that. Right, you don't want to have an AP every 20, 25 feet. That just gets cost prohibitive for the little bit of added value. But I do think you're going to need a reasonably dense deployment. I think if you're 11N today and you have a good 5 gigahertz plan for capacity, you're very likely going to be able to do a one-for-one replacement with 11AC. Because we're seeing similar receive sensitivities, and obviously the transfer powers are limited by the FCC. So we're seeing about the same coverage area coming in.
Are they in those types of deployments with the 2.4 side of that still being in-based? Are you turning off the 2.4 on some APs with that type of deployment?
That's an option we've actually had on the Aruba side for a long time called mode-aware arm. Will detect when you're oversaturated on 11N, on 2.4. It will turn them into air monitors. They just become sensor radios listening.
But the 5 gigahertz radio is still running and the 2.4 is just doing monitoring?
Yep.
Okay.
With regards to the coverage that you mentioned, just a specific question on the access point. Are they still down tilt antennas like the 105s and 135s?
Yes. Their internal down tilt antenna is very similar. We do support transmit beamforming with the 225. If you have a 11AC standards compliant transmit beamforming client, you will get that. We've seen some pretty good results from our internal testing. We need to do more before we can share much of that, but we're seeing about a 1 MCS boost in some locations.
So you mentioned in the design phase the one-to-one replacement. What about the cabling requirements?
Yes.
Lee at Wired Knot had posted about.
I was about to
let's get to a 2 gigabit Ethernet, because we don't need 10 everywhere to the edge, but we might actually need a 2 to the edge to make these guys, especially on Wave 2, to make them play, and rather than pulling 2 Cat6 cables everywhere. That's an expensive option.
He also has some other suggestions as well, other things that you can do with low voltage cabling out to the APs. It's
going back to the early
creative.
days, pre-PoE days, no voltage
Yeah,
cable.
just make up a whole new Ethernet.
No, I think that feedback, we've thought about it ourselves, talked to a bunch of silicon suppliers on the switching side to figure out if there's a version of gigabit we could rate it up to 2 gig or 2.5. There are some proprietary techniques out there. Unfortunately, there's no standard. So we'll have to, I think Wave 2 is the right time. It's still 2-3 years away. And doing this requires an ASIC spin on the switch as well as on the AP side. So you won't see this anytime soon, I would say, in the market for the next 2-3 years. But maybe after that, it is something for us as an industry to consider and come back with.
So in the short term, would you recommend, if we're doing a new design today for AC, pulling 2 cables to every AP location?
If you want the extra throughput guaranteed, then that's the only option you have. I don't think there's any other practical choices at this point.
I would say it's a reasonable consideration. Obviously, everyone needs to make their own cost-benefit trade-off on improved performance. But if you're pulling a new building, it's definitely something to think about. If you're in an existing building, there's no need.
Can you offset that cost by having dual AFs
Yeah,
to drive
I was
it
going to ask.
rather than AT?
Today on the AP225, it needs to be a single port. You can do kind of PoE failover. So if you're kind of pushing to 2 different switches and one goes down, the other will come up and power the AP. But you can't do 2 AF to add in.
Just trying to find cost savings.
Yeah.
Right now,
One side or the other.
Yeah.
it makes sense. I think some of the cost savings really, though, comes in from right sizing, right? If you're in that second wave of 11AC and you're pushing larger throughputs, can you pull back ports in other areas and start to kind of reduce the overall switch spend?
You said the failover, you can do a PoE failover, link failover between switches. Is it running a spanning tree, or is it a configurable option to shut down the port until failure? How does that work?
I need to double check. I don't remember the exact details. I know you can power both ports. We'll just pull from one, and if that port goes down, we'll bring up the other port. I'm not entirely sure from a spanning tree point of view or anything like that. I mean, from a PoE point of view, I think it's literally we just detect PoE isn't coming in on one, we bring it up on the other.
Yeah, it's not both active. Both the links are not active. Only one link is active at any given point. So you don't need to run spanning tree out to the AP. Only if it detects power failure will the second link actually come up and draw the power. So it's an AP reboot. It doesn't stay up through the actual switchover, which makes you select basically one link at a point at a time.
You know, when
If you're ganged up to the same switch, then you can run Ether channel on it. But you're not drawing power on it.
Are you running LACP? Is it standards based, or does it require Aruba sub?
No, it's totally standards based. It'll work with any switch out there.
So we're talking about the bandwidth throughput from the wired side connection, though. I mean, I think we really need to look at what is the device explosion that's going to happen. You know,
when is the device explosion?
Yeah, we're looking right now. We see
After Christmas.
mobile devices are the primary ones that are getting the chips right now. There's the rumor of at WWDC we'll see the
after
the
WWDC.
Macs. You know, we'll see the Mac products that possibly will have an AC chip in them. But you know, when I look at what we're looking at from a throughput point of view coming out of the access point, it comes down to the device that's using it. You know, if I've got a bunch of these tiny screen devices doing a kind of small bit rate down onto it, do I necessarily need the 2 1 gig links right now today? Even on a laptop, I would go as far as saying possibly not needing that 2 1 gig links today. Again, I think it comes down to, like we talked about, is the wave 2 is really when we're going to start seeing the actual need for better throughput to the access point.
The infrastructure questions those are much more, the cabling is a much more long-term investment.
Yeah, true.
And if you're trying to be forward-thinking, that's one of the options to look at.
Somebody's doing an upgrade from like G today, they're looking at possibly AAC as the next wave of going to that, and maybe pulling cables in for a different AP design in their site. So they'll possibly be looking at, well, should we be pulling extra cables in while we're doing that?
Right, and I think another piece coming in is if we're looking longer term, wave 2 or 3 years from now, if multi-user MIMO works, right, even though you're on a bunch of single stream devices, you can actually be pushing out to 3 or 4 of them at once.
Yeah, the aggregate data will make a difference.
And so then kind of the stream count of the device disappears on the downlink side, and you start getting the aggregate throughputs that are going to come up. And we saw today in the demo, UDP, we pushed 920 megabits of traffic, right? Those actual real-world throughputs. Throw a user on the 2.4, you could go a little bit beyond that. But that was a single user that is 3 stream. You know, if I let you associate that with your phone's obviously going to bring down the overall throughputs. And that's why we say, you know, if you're in an existing real-world deployment, you don't need to pull an extra cable. If I'm planning 2 or 3 years out, it's definitely something to consider.
But back to what Chris was saying about moving from G, people who skipped N and they're sitting here now, it's not just the AC. As we move to wireless as the access layer, your wired layer that you have has to be more robust.
Right.
I mean, there's a big investment on that side as well.
I think one of the things that's funny is if I look back at in my customer portfolios, like who would possibly be ready for this from a cabling standpoint? Manufacturing. I have a lot of manufacturing customers that run 2 leads to their access points, one hooked up to the console port, one hooked up to the access port, so that if they had an issue, because sometimes these are mounted 20, 30 feet up in a rafter, they need to get in the console. They're not going to get the scissors lift down the product aisles and interrupt fork traffic and everything. So I think it's kind of funny if we look at who's ready from an infrastructure standpoint. It was the one that was hardly ever ready and was still running the old symbol frequency hop devices.
Exactly.
Yeah. One of the other things that's interesting that we run into is a lot of people when they did ABG to 11N, they did 1-for-1 replacements, and they dropped it on 100 meg ports. And so they have 100 meg switch ports, and going to 11AC, they've got to figure out how to get gig on that switch. And they forget that switch only has a gig uplink to the core. So now all of a sudden they're going to have 15 11AC APs hanging off of 1 gig uplink. So not only do you need, is it recommended to have 1 gig at the switch, we'd recommend 10 gigs up from the switch.
Well,
that's critical.
That cascades upward as well.
Yep. It does.
Who said wireless was the bottleneck ever here?
So on that note too, what about mesh? What about doing AC mesh? There was a question on Twitter about that.
Yeah.
I think AC mesh is usable in certain situations where you can't pull cabling. Manufacturing floors could be one of those. Old classic buildings where you can't pull cabling and so on. But our general recommendation is when you can backhaul through wire, do it, because you're saving the air for the users rather than having to retransmit the same packet over the air multiple times.
We have another question from Twitter. Is the switch to 5 gigahertz by so many devices going to defeat the higher speeds possible in 11AC as the noise floor increases?
Well, that's unavoidable.
Defeat is a strong word because you've got to remember 5 gig has 3 or 4 times the amount of spectrum today than 2.4. The FCC is talking about opening up another 160 megahertz of space. So
one more channel?
Eventually.
195 megahertz.
Is it 195?
Yeah.
A fair amount of space. So true, that's one 160 megahertz channel. I personally don't see a lot of 160 megahertz channels getting deployed in a general enterprise. As a home user, that's great. General enterprise, I don't think you're going much above 80. So that will happen. I mean, as we hit more devices, we're going to hit spectrum issues, but as 11AC speeds up, 256 QAM, some of the other features coming in, we're trying to use that spectrum more efficiently as well. So
I think it does mean using the DFS-enabled channels becomes a lot more important. So DFS certification on access points, how well they do it, becomes a pretty important criteria. Otherwise, you're limited down to the non-DFS channels, which is
I liked in your client match that you were tracking devices and saying this device acts a certain way, not only for your client match, but which channels can they support? Where they all don't play nice the same way.
Yeah.
And it's sad, but that's kind of where we have to be, that we have to treat them differently.
Yeah, client DFS support is a big thing. We want to see 100% of all clients support DFS, but we're not quite there.
I think it's interesting that they've written into the standard the frame-by-frame detection of who's actually using the bandwidth. So if you've got somebody that's using 160 megahertz and there's somebody else out there only doing 80, it will drop down to the 80 to be able to make the protection for that client still work.
And we thought that troubleshooting Wi-Fi was complex before.
Right.
That's what we don't even have the tools to even look to see what they're doing right now.
You don't need no tools.
No, but it was a good addition to the standard, which will hopefully allow us to deploy 80 megahertz channels. A lot of times in high-dense environments today, like an auditorium, we actually recommend 20 megahertz channels because you're better off having small pipes because a lot of the packets are small. So getting through its packets per second issue rather than the bandwidth issue.
I think Keith done for some testing that he was doing the 40 megahertz channel, he was actually getting much higher throughput from the clients. So
in high density?
Yeah. I used to be a 20 megahertz guy all the way. I've moved to 40 because the net effect for those certain devices that can do it, surpasses what I had thought it could do.
We did a lot of testing in a university environment. So there's a lot of BYOD, a fair number of tablets.
It's kind of a timing, though. I tested with V4 iPads that could support 40, and once you get over some level of how many of your devices are 40 capable, all of a sudden you get a huge change. So maybe not this year, but within the next. I mean, all devices from now on will be 40 megahertz.
Right. Well, hopefully 11AC will solve that problem for us in an average RF environment. so that we
I
can
think
go 80
it's
megahertz.
interesting that gives the possibility of being able to deploy with 80 megahertz channels because you know that the APs will be able to handle it in a much more intelligent way of supporting those clients that aren't supporting that wider bandwidth.
Right. And the critical thing being making sure the APs have the intelligence to pick the right 20 and 40 megahertz primary channels so they get staggered across all the APs, even though they might be overlapping on the 80 meg. So that when they fall back, they're not falling back to the same place.
Before I go to the next question from Twitter, are there any questions in the room that anyone would like to ask? We've got quite a few people here with us. Anyone?
Link aggregation is supported, correct?
Link aggregation?
Link aggregation on the AC access point.
Yes. LACP capable? I'd have to double check.
I'm not sure right now, but we can get back to you on that.
Yeah, I saw that question online as well, actually, regarding LACP. How about Turbo Quam from Athros Chipset? Turbo Quam just sounds exciting to me.
Turbo Quam is a Broadcom-specific capability. It's not supported on other chipsets, but where available, I mean, for example, the Samsung device actually supports Turbo Quam on 2.4. We can support those. And if you look around on the client side, there's a lot of Broadcoms out there on mobile devices. So we hope to take advantage of it in 2.4.
Right. And the big thing it is 11AC uses a bunch of different ways to be faster. They use wider channels, multiple streams, but the higher modulation, right, going up to 256 QAM, there's no technical reason why that needs to be 5 gig versus 2.4. Wider channels clearly have to be 5 gig. You can't fit them in 2.4. But the higher modulation is getting kind of pulled down into the 2.4 gig space. So it's 11N plus some additional modulations to try and get better throughput. So on a 3-stream device, in theory, you could get up to 600 megs. On a single-stream smartphone, you could get up to 200 megs if it's supported on both the AP and the client.
With appropriate SNR.
With appropriate SNR, of course. Yeah. Max connected data rates would be 200 instead of 150.
How's client match going to work with your instance? Is it going to be exact same functionality? Is there going to be a difference?
It's planned to be the exact same functionality. Okay. So it would just be that kind of virtual controller set of APs would be sharing the information. Because client match is actually a bit of a distributed architecture. The APs hear everything. They feed that up to the controller, which aggregates it and shares it to the AP of association, which is then doing the decision-making process. Because we're actually evaluating the sticky clients every 3 seconds. On the 7240, we support, I think, 32,000 clients. So looking through 32,000 clients every 3 seconds to make sure they're best placed is a little tough when you're in a centralized area. Pushing it down to the AP makes that much easier. So in an instant world, we can do similar things. It'll be a smaller set of kind of client views because there'll be fewer clients on the smaller cluster than on a 7240 with 2,000 APs. But it'll build that up, push that down to the AP. The AP will decide whether or not it's healthy, pass that back to the controller, which can then coordinate the move.
It seems like there's a dilemma, though, between something Pascal had said. We want to limit the off-channel scanning, and yet to see those other clients who are on another AP, we have to off-channel scan.
Not always. Some of the traffic from the clients will actually hit across channels and can be used as well. If they're sending in probe requests, for instance, we'd be able to see that across all the channels because they'll go off-channel. Because Pascal was also mentioning that client devices tend to go off-channel whenever they feel like it. And so we can leverage that. While that might cause links and problems with those devices that get smaller, when they go off channel and share information, we can hear that and use that information to build up signal maps.
So one of the things that you were talking about was the ability to say you've got a particular client connected, say doing a link session that's got a MOS score that needs to be kept up, and having the AP making enough intelligence for a decision to move other clients off that. How would the AP be able to figure that out without dropping some packets to scan where to move the AP, the clients off?
So if we use a slightly simpler example, you can say the same thing with spectrum load balancing, right, or moving when there's too much throughput. The controller has the view of each AP's throughput and performance, and so when it builds up that client's view, it has a lot of moving parts. I'm trying to think of the best way to explain it. So say I'm associated to APA, and there's AP B and C around. The controller will actually say APA is 10% loaded APB, 20% APC, 50%. And then it'll say Peter can hear A at minus 75, B at minus 50, and C at minus 20. And that whole set of data will get passed down to the AP that I'm associated to as what we call the virtual beacon report.
Okay.
So then the AP has context of not only the user signal strength from all those APs, but also their load in terms of client count and throughput through those APs. And
So
that
it
could be
doesn't actually
extended.
need to switch to
Correct.
scanning mode to actually find that information.
This VBR is really the heart of client match, going out and building, because we were expecting to get real beacon reports from 11K enabled clients.
Right.
And we do use it where it's available, but the vast majority don't have 11K. So we had to kind of figure out on behalf of the client, how do we build a beacon report? And that's kind of what we collect information. That's the measurement process. And then we figure out at a system level, across all clients, what are the best algorithms to invoke and who to
Is there actual additional information you're getting from K clients that'll feeding into that
when
as
we
well?
when we get information from K, we'll substitute the virtual computed SNR to the real SNR that the client is actually seeing, but the process remains exactly the same. We construct this beacon report and use that to enable clients.
Are you pretty close with your non-K clients to getting
Yes.
an idea of what they are?
Yes, in fact, that was the first analysis we did was when we built a prototype. We were like, how far off are we? And we are off, but it's off by a fixed offset. And once you know what that offset is, then you can actually
Is that offset by client or offset by location?
It's
Per client, it's kind of
offset
a
by client.
safe sensitivity.
It was like a few dB, 3 or 4 dB off, but we knew exactly it was within that range.
And it stayed there.
And it stayed there. So we were like, okay, let's just add that to the computation, and then you end up with a fairly precise calculation.
So basically, you don't need anything at all on the client. You can support as old as you want.
That's right.
Yes.
That's right.
Client match is supported on all clients. We prefer to use the standard when we can, but if we can't, we have ways of figuring it out.
And that is a pretty important issue because we moved away from, if you look at all radio management algorithms in the industry until now, they're purely optimizing the radio on the AP because that's all they control, including band steering. When we introduced it, we're doing a lot of blind steering is what I think about. When we're steering off to 5 gigahertz, we started to get some cases where the client was actually able to see the AP better on 2.4 than on 5, but because it was 5 capable, we'll just move it anyway. And it's true for us, it's true for a lot of others as well. And then we started to say, okay, let's take a step back and figure out how to make this more intelligent. And it almost always came down to the client's view. What is the client seeing and what's the best decision on behalf of the client to make? And that's the result of what
I'd like to
client
take
matters.
that quote. It's all about the client because it's all about the client.
Absolutely.
Well,
It is.
another thing that we saw was that client drivers optimize for themselves, not necessarily other clients. So we want to take that client view into account with all the network information, right? So it's not just about the SNR to the AP. We need to know that AP is loaded, what's going on with that AP, right? With the link example of we see voice and video running here, we want to push people to other APs. We need to know that the clients can be healthy where they end up so that we can kind of free up space. So you need to have a combination of both the client and the network. If it was literally just the clients would make wonderful decisions. We'd never have any problems.
I know we're inside of Aruba today, but is there a way we could put that in the protocol itself? I mean, the things we're discussing, what you've done, should be for all clients everywhere.
Absolutely. I think the protocols are there. They're called 11K and 11V, but they're not getting there, right? And that is the reason we had to take a step back is, I mean, the whole certification program also exists with WMM and Voice Enterprise, which we're trying to push out with Microsoft, and we just didn't find the devices actually supported. Some of them are stepping up, and 11K, 11V are available. 11K is available on iOS for now. At this point, I think some of the Microsoft devices have them as well. So where it's possible, we'll take advantage of the protocol, the standard protocol to collect information. The thing you cannot standardize is the algorithm of arriving at that best decision. That's really the trade secrets, where you're looking at what is actually going on and making the best possible decision. And we'll leave it to the performance benchmarking gurus to tell us which ones work better than others out there.
But very much on the side of gathering information and the side of steering, we'd love to leverage standards as much as possible.
Yeah, how do we beat up the client guys? That's
Is there a component of that actually exists at the iOS level that could be improved by iOS manufacturers as well? So like Microsoft with their phone, for example, they could improve in their phone and the Surface tablet to use the information that's being provided by K&D in their client implementations and things to improve performance from the client level.
Do it on the device versus versus an application.
But, or feeding the information back to say, client match to help with the roaming of clients.
Yeah, I mean that's another option is the app. There's some collector running a small app running on the device and feeding it off of 11K. And what we've found is, clearly you can do this in Android because there's a lot of wealth of information you can hack through. But iOS, you're limited to what the driver APIs provide you information with. A lot of times we don't get that level of information in an app to be able to circle back to the network side. But fortunately, they have adopted K and R, so we'll be able to collect information in the newer versions of iOS directly. But it is a pretty thorny problem. It's a driver level issue at this point.
I have to interrupt because we're running very, very short on time. We do have one more question from Twitter that I'd like to get to, but then we're going to take a little break. So the question is, are there any issues with mixing 11AC APs with BGN APs?
So we would not recommend putting ABG and 11AC side by side, just like we didn't recommend putting ABG and 11N side by side. With the MIMO and the change in the rates that you see, we see clients tend to be very sticky, where when they can be on 11N, they'll stick to 11N, even if they're right next to ABG, and vice versa. Right? We can solve some of that with client match, but I'd rather not design a network into a known problem. As far as 11N and 11AC being side by side, I don't think we're going to see any issues. You've got to remember we have an 11N radio inside the AP already, so not having them side by side is impossible. Having 5 gig 11N and 11AC side by side shouldn't be a big difference because we don't have changes in the coverage patterns, right? MIMO is there in 11N and in 11AC. And additionally, the data rates are very similar. 11AC adds a few at the top, but as soon as I get far away from the AP, I'm going to fall back to 11N data rates, and there's no reason to prefer the 11AC AP over the 11N AP that's right next to me that would give me a higher 11N rate. So we don't expect to see any issues with that.